limits to infinity. So when we talk about infinity, we're talking about a large positive or a large negative number. And just so you know, we don't ever do one-sided or outside limits. We don't ever do to the positive power, like coming to infinity from the right. We don't ever do going towards negative infinity from the right or the left. So those are not options. You're either going large or small. So you can think of the graph for this one. So y equal x cubed, you know this is the graph. X's are getting larger, the y values are getting larger. This here, same with y equal x squared, that's infinity as well. So looking at the graph of root x, you can see that that goes to infinity. And so let's just kind of think about what this means. So what this means is if I take infinity cubed, I get infinity. If I take infinity squared, I get infinity. If I take the square root of infinity, I get infinity. So we're going to start to be playing with infinity, so once you get comfortable. So we did talk about 1 over x before, but let's just kind of revisit it. So if I've got the graph of 1 over x, as x's are getting large, you can see this is 1 over infinity, so that's 0 going out there. And then if as x's are getting very, very small, going to negative infinity, this is also 0. So let's think about the graph of e to the x. So e to the x looks like this. And so as x's are going to infinity, that goes to infinity. And e to the negative x, you know, is this right here. As x's are going to infinity, think about it. Doesn't that go down to 0? So let's think about what this means. So this means e to the infinity is equal to infinity. And this one gives us e to the negative infinity gives us 0. So you can think of e to the negative infinity as 1 over e to the infinity, which is the same thing as saying 1 over infinity, and that's 0. So again, let's think about these graphs. As x's are going to infinity, I've got ln of x looks like this. So that's going to infinity. And so what that gives me is ln of infinity is infinity. Let's think about sine of x and cosine. So let's see, sine, you know, looks like this. So as x's are getting large, as they're increasing without bound, what one y value is the limit going towards? There's not any 1. It keeps going back and forth between -1 and 1. As a result, that limit does not exist. Same thing with cosine. So cosine, you know, looks like this. It continues to go between 1 and -1 as x's are getting large. It's not going to any one y value, so that does not exist. So if I've got some number r that's bigger than 0, so it could be 2/3, 1/2, 6 over 1, but positive number, and it's in the denominator, I know that that infinity is going to be making that whole fraction equaling 0. So let's just go through some examples. So here, if I have -5 over infinity squared, that's -5 over infinity, that's 0. This is saying go to negative infinity. So I get -5 over negative infinity. That's still a number over infinity. That's still 0. Doesn't change the sign. Here, a number over infinity to the 4th power. That's still going to be a number over infinity. That's 0. So when this denominator here is a positive exponent and you're plugging in infinities, you can see, oh, look at this one. You'd have -4 over a negative infinity cubed. Won't that give me a negative? So I'd have a -4 over a negative. But hey, wait a minute. That's still just going to give me 0, right? Because it's a 4 over an infinity. Here I have 4/3 times 1 over root x. That's still going to give me 4 over infinity. That's 0. And this one here to the 2/3 power, even if it's negative, it doesn't matter. 2 means the power here 2 means square it and then cube root it. And it's still positive, but it's still -3 over infinity. That's 0. So all of these cases fit this. So what do we do when we've got infinity over infinity? That's where we need to do more work, just like with the 0 over 0. So the more work we're going to do, just these simple examples, is we're going to cancel. So we're going to cancel the x's. So I get a negative 5 over an x squared. Then I plug in infinity, 5 over infinity squared. That's 0. This one here, again, remember to write the limit down every single time. Cancel an x, so I get negative 5x. Oh, I'm plugging in negative infinity in here. So I'd have a negative 5 times a negative infinity. That would give me a positive infinity. So in this case, the sign matters, right? So let's go to this one. Limit as x goes to infinity. Cancel an x. I have negative 4x squared. So I'm going to positive infinity. So I put the positive infinity, it's squared, but then I multiply it by a negative 4. So this answer is negative infinity. This one here, let's do some more canceling. X is going to negative infinity. So I would get 4x, put in the negative infinity, 4 times negative infinity, negative infinity. And you know how to cancel e to the x's, right? So you know this is the same thing as saying 4 over e to the 3x. Put in infinity, e to the infinity is infinity, 4 over infinity is 0.